a couple of problems with non-homogeneous linear equations. So, let's solve 1 second minus 5y prime plus 6y equals to e to the power 4x. And let's put initial conditions here. So there's an IDP of 0 equals to 0, y prime 0 equals to 0. I put them both 0 so that it's hopefully easier to calculate. Okay, so there's an example of a non-homogeneous. Why non-homogeneous? Because we have non-zero on the right-hand side here. So what's the single most important theorem about non-homogeneous equations? So the general solution is of the form y equals to y sub c plus y sub c. That's the theory. Let's see, in 1 minute theory. Y sub c is the general solution of y second, in this case, minus 5y prime plus 6y equals to 0, which is the associated homogeneous equation. Right? And y sub p is a particular solution, as in any particular solution, of the non-homogeneous equation. Y second minus 5y prime plus 6y equals to 0. So let's go ahead and do y sub c first. So what's the characteristic equation for y second minus 5y prime plus 6y equals to 0? We write it down r squared minus 5y plus 6 equals to 0. Vector it, right? Or if we don't know, we don't see right away, apply the quadratic formula, but we do see right away. So r minus 2 times r minus 3 equals to 0. Characteristic roots are 1, comma 2 equals to 2 and 3. Real and distinct, right? Therefore, y sub c will be c1 e to the power 2x plus c2 e to the power 3x. So keep this in mind. This is the first half of the, so to say, so first half of the problem. Okay, so this being said, let's do now y sub t. So this is called the method of undetermined coefficients. So this method consists of following idea. So look at the free term, which is e to the power 4x, and start differentiating the free term over and over and over again. And then at the end of the, when it becomes cyclic or it repeats or gets down to 0, look at it and see which are the linear independent terms which appear in the process of successive differentiation. So if we do e to the power 4x, which is the free term, differentiate, what we get? 4 e to the power 4x. Differentiate 16 e to the power 4x, and so on. But nothing new. So, because I said linear independent terms, there is only one, essentially one term. So, basically, it's only one linear independent term which appears in the process of successive differentiating the free term. Therefore, we are looking for y sub p of the form a e to the power 4x. There is a fine print here. So, this works if there is no interference, no overlap with the basis of solutions of y sub c. What's the basis of solutions involved in the complementary function y sub c? These are e to the power 2x and e to the power 3x. So no overlap between this e to the power 4x and those two things. Right? So therefore, so if it was overlap, then we have to solve it, try some different tricks, multiply by x and stuff like this. So we'll see, right? But let's finish this one. So we are looking for a particular solution of the form a e to the power 4x. So what does it mean particular solution? We need y sub p to satisfy the differential equation y second minus 5y prime plus 6y equals to this, right? So yp second minus 5yp prime plus 6 y sub p equals to e to the power 4x. So we got y sub p. Yp prime is what? It's 4a e to the power 4x. Yp second is 16a e to the power 4x. And then replace y sub p in the equation. So what will be yp second minus 5yp prime plus 6y sub p. So this will be what? 16a e to the power 4x minus 5 times 4a e to the power 4x will be minus 20a e to the power 4x plus 6a e to the power 4x equals to the three terms should be e to the power 4x. So what we got here? 6a minus 20a plus 6a will be 22 minus 22, 2a. So after doing algebra here is 2a e to the power 4x equals to e to the power 4x. Right? So a equals 1 because we can simplify e to the power 4x being non-zero. We got a 1 here. So a equals to 1. Therefore a equals to 1. So a equals to 1/2. So after everything is said and done, what will be y sub p? Yeah.
These are negative 20 AE.
So this is yp second. This is minus 5yp prime. Yp prime is 4a e to the power 4x, right?
Oh, I got it.
4 minus 5 is minus 20. Sorry, I was speeding it up at some moment, right? Plus 6a e to the power 4 is 6 y sub p, right? Again, yeah, 6 y sub p. Okay, so let's kind of, so we are now confident that we got, this is the method undetermined coefficient. A was undetermined, but now we determined it, right? We found that A equals to 1/2. So put everything together and erase everything and only write down the conclusion. What was y sub p? 1/2 e to the power 4x, right? Because we got A equals to 1/2. So can I erase this stuff? So there's any more space? Okay, so y sub p, after all of this, turns out to be 1/2 e to the power 4x. Okay, so now what's the general solution of the non-homogeneous equation? Y equals to 1/2 e to the power 4x again y sub p plus c1 e to the power 2x plus c2 e to the power 3. That's the general solution of the non-homogeneous equation. But now let's take care of the initial value problem, initial conditions. So when we have to deal with those two relations, y of 0 and y prime of 0, it is, I recommend that on the spot here write down y prime so that we can use the initial condition. Y prime will be 2 e to the power 4x plus 2c1 e to the power 2x plus 3c2 e to the power 3x. Right? Okay, so now let's translate the initial conditions. So y of 0 equals to 0 means what? So equivalent. If we say 0 here is 1/2 plus c1 plus c2 equals to 0. So c1 plus c2 equals to minus 1/2. How to translate y prime of 0 equals to 0? Is equivalent to 2 plus 2c1 plus 3c2 equals to 0. 2 plus 2, we said we are setting x equals to 0. So 2 plus 2c1 plus 3c2 equals to 0. So 2c1 plus 3c2 equals to minus 2. Right? So that's a system of real equations, no more differential equations. So the system, okay. Let's find C1 and C2. So we can just include a preview of the linear algebra part, which we'll do next after this one comes linear algebra. So this kind of very fortunate because now we do some linear algebra Gaussian elimination. So imagine, take the first equation, multiply by -2, and add the second equation. This is the strategy. We'll discuss at length about this. Right? Why are we doing this? Just to cancel this term, right? So the first equation remains the same, so C1 plus C2 equals to -1/2. But the second equation becomes much more convenient if we do this operation. So we cancel multiplying the first equation by -2. There's nothing here. So C2 equals to 1 is -1. So we got it on the spot right away, right? If we do this process, this trick, right? That's called Gaussian elimination, right? Now, once we got C2 equals to -1, plug it in here. So what is C1? C1 is this C2 equals to -1, move it to the right, C1 equals to 1/2. So y equals to 1/2 e to the power 4x plus C1 plus 1/2 e to the power 2x minus e to the power 3x. So this is the solution of the initial problem for the non-homogeneous equation. Any questions? Okay, so let's do our life harder. Let's have one which has overlap. What is overlap? When I do the trick with the excessive derivative of the three coefficients of the three terms, we have interference. Some of them overlap with the base of solution for the y sub c. Right? So let's pick one problem like this. Okay, so exercise 2. Again, another easy problem. Y second minus y equals to e to the power x, and y of 0 equals to y prime of 0 equals to 0. Okay, we don't have to put both 0, but I just, the part with initial condition is not difficult. So if it's not difficult, why don't I put it the easiest way anyway? So okay, so y sub c first. So how to solve y second minus y equals to 0? Well, r square minus 1 equals to 0 is the characteristic equation. Which are the roots? Plus minus 1, characteristic root. So y will be y sub c is c1 e to the power x plus c2 e to the minus x. Because the characteristic roots are 1 and minus 1. It's very important, so just keep in mind. So we are through half of the. Also, those halves are not necessarily equal, let's say. Okay, so y sub t. Okay, so as always, take the three coefficients e to the power x, differentiate with nothing more, right? So at first sight, we have to say, well, why don't we try y sub t equals to a e to the power x? But this is not good because we have interference with one of the terms with the so overlap with one of the terms. So that's not good. Not good because of the overlap. What overlap? This to the power x will overlap with this component of the complementary function y sub c. And then we'll try to find an inspiring trick exactly like we did when we solved linear homogeneous constant coefficient with multiple roots. Multiplicity of a root repeats, put an extra x. Right? Let's try the trick here. Right? So instead of this not good, instead try y sub p equals to ax to the power x. So if this will be no good, if for example, if we got x, one double root here, to one more x. So x squared to the power x until we multiply with the minimum power of x until there is no more overlap. But we are already there, so no more overlap at this moment. So now we want to find a constant a such that ax to the power x satisfies the non-homogeneous equation. Right? So as always, calculate yt prime. Be careful with the product rule here. So ax multiplied by e to the power x. So the a to the power x plus ax to the power x is derivative. Product rule. One more time, yt second is a to the power x. And one more time, do the product rule here. Plus another a to the power x. Plus ax to the power x. It should be 2a to the power x. Plus ax to the power x. There's the second derivative. Right? Then, introduce everything into a differential equation, which is this one. So what would be yp second minus y sub p? Is 2a to the power x plus ax to the power x. That's yp second. Minus y sub p is minus ax to the power x. Should be to the power x. This is a clear indicator of success because we had this simplification. Otherwise, we have been in trouble to equalize something which is only e to the power x, and here on the left we have e to the power x and x to the power x. But now, this to simplify, we are in a very good position because we got 2a e to the power x equals to e to the power x. So, on this implies what? Half a. So once this to simplify, we are out of the game. So what's left? 2a e to the power x equals to e to the power x. Hence a equals to 1 half. Right? So y sub p equals to 1 half x e to the power x. Oh, by the way, this just happened. Don't believe that a will be 1 half in all the problems. So let's try to take another last look and see if everybody understands this, because I want to save some space here. So I only need y sub p equals to 1 half x to the power x. So let's take some space. We got this one, we got y sub c. So what's the general solution of the non-homogeneous? Ds of non-homogeneous. Y equals to y sub p plus y sub c. So y will be 1 half x e to the power x plus c1 e to the power x plus c2 to the minus. Right? Now we have to give me the initial conditions. So on the spot, let's write down y prime. Y prime will be 1 half e to the product rule here, 1 half e to the power x plus 1 half x e to the power x plus c1 e to the power x minus c2 e to the minus x. Right. guys okay with that? So let's translate the initial conditions. Y of 0 equals to 0 means what? If I set x equals to 0 in here, C1 plus C2 plus 0, because of this x, this is a 0, right? So what will we get? C1 plus C2 equals to 0. Because if this x equals 0, C2 times e to the power 0, C1 e to the power 0, the exponential over 1 plus 0, because x 0 times something anything is 0. So C1 plus C2 equals to 0. Y prime of 0 equals to 0 means y prime is this one. So 1/2 plus C1 minus C2 equals to 0. 1/2 this is 0 plus C1 minus C2 equals. So C1 minus C2 equals to minus 1/2. We got this one, we got this one. How to find C1 and C2 from these two? What about if we add them together? If we add them, it's very convenient to add them together. So what we get here? 2C1, C2 will simplify. So 2C1 equals to minus 1/2. So C1 equals to minus 1 over 4. And because C1 plus C2 equals to 0, C2 equals to 1 over 4. Right? Because their sum is 0. Okay, so what is the general solution, the final result of the problem? Y equals to, let's take it from here, 1/2 x e to the power x plus C1 is minus 1 over 4. Minus 1 over 4 times e to the power x plus C2 is 1 over 4 e to the minus x. And this is a general solution of the non-homogeneous equation. Again, take a last look and put everything together, see if it makes sense. So what we'll do next? Next we'll do a similar equation with this one, but let's say, so far we try second order. Let's try one of order 3. But let's try to also, when you get to order 3 or more, at some moment the computation becomes tedious. Right? So let's try to keep the idea of order 3 and do less computation is possible. The third order, an increasing third order example. Exercise 3. Okay. Y third minus y second equals to 6x minus 8. Now, I want to put initial conditions. How many initial conditions we need for third order? For first order, we always need one condition. For second order, we need 2. And obviously now for third order, we need 3. So let's put the simplest possible initial conditions. Y of 0 equals to y prime of 0 equals to y second of 0 equals to y of 0 equals to y prime of 0 equals to y second of 0. So that's the problem we want to solve. Okay. Y sub c. What I have to do? Y third minus y second equals to 0. This associated homogeneous equation. Y second, y third, sorry, minus y second equals to 0. Characteristic equation, r cubed minus r squared equals to 0. R squared times r minus 1 equals to 0 is down to factorial. Which is the list of characteristic roots? 0, 0, and 1. Right. Based on this, what's y sub c? Because 0 is a double root. So c1 e to the power 0x, which is c1, just c1, a constant. Plus c2x e to the power 0x. So what we write? c2x. Plus c3 e to the power x. You know, the duo c1 plus c2x reflects the fact that 0 is a repeated root. Right? Okay, so we are done with y sub c. Okay, y sub p now. Now again, let's start with the messy calculation. So free term will be 6x minus 8. Differentiate, get a 6. Differentiate, get a 0. And then if you differentiate, you get nothing new. Right? So what's the list of linear independent terms which appear in this? Forget about sums, multiples, constants, and stuff. Only the basically independent terms appear in this process. We see a constant which is a 1. Always we see a constant which is not 0, put a 1, right? We see a constant which is 1, we see an x. So only 1 on x is certain. 1 on x. Right? So there's a list of all linear independent terms which appear in the process of successive differentiating the free term 6x minus 8. So at the first sight, it will be no interference or no overlap. Y sub p will be a times the first one plus b times the second one. So a plus bx. Is it good? Not good because there is big overlap with c1 plus c2x. That's not good. Then what? We have strategy. Can we multiply by x and make it good? So maybe y sub p equals to multiplying by x is ax plus bx squared. Do you still have overlap? Still no good. Because we have overlap between ax and c2x here. So still not good. What about then y sub p equals to ax squared plus bx cubed. Now, for the first time, we got free of this c1 plus c2x. No more overlapping here. Right? So now this is it. So which will be our undetermined coefficient? Undetermined is not yet determined. They will be determined, right? So are a and b. Okay, so like always, let's try down to calculate derivatives so that eventually I want to replace them into the equation. Y prime is 2ax plus 3b squared. Is it visible at this point? Well, let me try to write higher on the board. So y second will be what? 2a plus 6bx. We need one more. We need yp third because the equation is third order. So yp third equals to 6b. Now, the only thing we have to replace now is to yp third minus yp second to be 6x minus 8. So yp third minus yp second. What will be this? Yp third is 6b. Minus yp second is this. So minus the parenthesis 2a plus 6bx. Right? Place yp third minus yp second. In order for y sub p to be indeed a particular solution, yp third minus yp second should be 6x minus 8. So we want to determine the undetermined coefficients as of now. So that this should be 6x minus 8. So here, point A and B, this is 6x minus 8. let's try to open the parameters here, and 6b minus 2a minus 6bx equals to 6x minus 3. Now, let's start to equalize. What does it mean equalize? Equalize the coefficients of the like powers of x on the left and on the right. What's the equalize the x to the power 1? What's the coefficient of x to the power 1 to the left? Minus 6b, that's what equalizing. Minus 6b. What's the coefficient of x to the power 1 on the right? Is 6. Right? Which x to the power 1 to the right is 6. So we got b. So what is b? So this implies b equals to minus 1. Now, what else should we equalize? Coefficient of x to the power 0 to the left and the right. What's x to the power 0? 3 coefficients to the left and the right. So x to the power 0 is equalizing, which is constant. Constant to the left, 6b minus 2a. This constant on the left. Constant on the right, minus 8. Okay, now that we know that b is minus 1, right? No, we know that b equals to minus 1. We use it here. What is the a? Here we know. A equals to 1, right? So, because this becomes minus 6, move minus 6 from left to right becomes 6. 6 minus 8 is minus 2. So, minus 2a equals to minus 2. A equals to 1. Excellent. So, b equals to minus 1, a equals to 1. So, from these two, what will be y star p? Y star p was, what was y star p? This one. Ax squared plus bx cubed. A is what? X squared minus x cubed. X squared minus x cubed. Y star p is x squared minus x cubed. It's a very nice y star p, right? Without too many fractions and so on. Okay, so let's try to make some space here and write down all the result of our computation. Y star p equals x squared minus x cubed. And then forget about the scrap paper. So let's put here y star p equals to x cubed minus x cubed. So let's see how to go from here. General solution of the non-homogeneous equation. Y equals to y sub c plus y sub p. This will be what? C1 plus C2x plus C3 e to the power x plus x squared minus x squared. Okay. Y sub c, which was this one, plus y sub p, we found it to be this one. Okay, now to deal with those three initial conditions now, right, we have to on the spot differentiate into y prime and y second, right? So y prime will be C2 plus C3 e to the power x plus 2x minus 3x squared. That's C2. That's y, sorry, this y prime. Y second equals to C3 e to the power x plus 2 minus 6x. Right? Now let's translate each initial condition. Y of 0 equals to 0. Y of 0 equals to 0 means what? If we set x equals to 0, we'll get what? C1 plus C3 equals to 0. Are you guys okay with that? Y prime of 0 equals to 0 means what? C2 plus C3 equals to 0. My second of 0 equals to 0 means what? C3 plus 2 equals to 0. So C3 equals to minus 2. C3 from here plus 2 minus 0 equals to 0. So C3 equals to minus 2. And that's a system of very simple system. 3 equations, 3 unknowns, out of which one is already known, right? So C3 equals to minus 2. Again, C1 equals to minus C3, C2 equals to minus C3 from the first and second. So C1 and C2 are both 2. Right? C1 equals to C2 equals to 2, and C3 equals to minus 2. So what's the general solution, not the general, the solution of the initial value problem? So solution of IDT is this one. So y equals to C1, 2 plus C2x, 2x plus C3 minus 2 e the power x. So C3 equals to minus 2 plus x squared minus x squared. And this is the solution of the initial value problem. And this kind of reflects very well the fact that how to find a particular solution multiplied by the minimum power of x such that there is no more overlap. This kind of things.